Hello and welcome to Aughton Math. In this edition of Aughton Math, we're going to talk about graphing quadratic functions. And this is the second of two lessons on graphing quadratic functions. Okay, so a couple things that I wanted to let you know about. If you see y is equal to negative x squared, remember PEMDAS in your application of any input for the x value as a function. Because regardless of the input for x, y is always going to be negative. Well, why is that? Well, y is equal to negative x squared is the same as y is equal to negative 1 times x squared. And in PEMDAS, remember, exponents come before multiplication. So in the case of x is equal to 3, you're going to square, or x is equal to 3, you'll square the 3 first and then apply or multiply the negative 1 to the x squared value. So it'd be 3 squared times negative 1, and that would equal negative 9. But regardless of what you put in for x in this case, y is always going to be negative. So if I put in negative 3, I would have negative 3 squared, which is 9. 9 times negative 1 is negative 1. So again, regardless of the input for x, in this case, y is always going to be negative. In the case where I have y is equal to, in parentheses, negative x, end of parentheses, squared, then whatever I put in for x will always make y positive. If I put in a positive value for x, it'll be negative, in this example, negative 3 squared, which is positive 9. If I put in a negative value for x, I have, in this case, if I had negative 3, it would be 3 squared, which of course would be 9. So again, remember PEMDAS, parentheses, I take care of the values in parentheses, and I square that value. And then I multiply, divide, add, and subtract. Okay, so let's talk about two different forms of the quadratic function. The first, we've talked about the standard form, and the standard form is what I have up here. Y is equal to ax squared plus bx plus c. All right, that was the first form that I gave to you. And remember, from that, we figured out that the axis of symmetry was negative b over 2a. And then given the result that we got for the axis of symmetry, and knowing that the axis of symmetry went through the vertex, we were able to derive the x value for the vertex. So once you have the axis of symmetry, you can figure out the x value for the vertex, and from there you can plug in the x value to find the y value. Now we're going to give you the vertex form and the intercept form. The vertex form by its name gives you the vertex, and the intercept form by its name gives you the y-intercepts. So let's talk about the properties of the quadratic function in vertex form. Now this is very similar to the absolute value function. And if you recall, the absolute value function was y is equal to a times the absolute value of x minus h plus k. And now we're just changing the absolute value signs to parentheses, and we're squaring that value. But everything else remains relatively the same. The vertex is still located at h and k, and now the axis of symmetry is equal to x is equal to h. So let's talk about the vertex for just a second. If I had an equation y is equal to x plus 2 squared minus 3, then the axis of symmetry is going to be hk. And remember, when we have a value in parentheses, this sign is reversed. So my axis, or my vertex, is going to be negative 2, negative 3. Okay? Now I know where the vertex is, I can tell you where the axis of symmetry is, because the vertex, right, indicates the x value for the axis of symmetry. So the axis of symmetry is just x is equal to this h value, or in this case, x is equal to negative 2. So remember, the axis of symmetry is just that line that divides the graph of the parabola into two symmetrical halves. The graph opens up when a is positive. In this case, we have an a value that is equal to 1, and when it's 1, we don't state it. And it's a positive 1 because there's no negative sign here. So the graph, in this case, in this example, is going to open up. The graph opens down when a is negative. So if I were to rewrite this function as y is equal to negative x plus 2 squared minus 3, then this graph would open down. Okay, let's talk about the function in intercept form. So the intercept form, remember, was y is equal to a times x minus p times x minus q. And this is similar to what you've already seen before in algebra. We're just changing some of the letters with variables, in this case p and q. So here I have a factored quadratic, which I could rewrite in standard form as y is equal to x squared minus 4x plus 3. So here's my C value, here's my B value, and my A value is just 1. Now I'm factoring that to put that in a different form. So it's the same, I tell my students it's like hair brushing. You're brushing your hair, it looks different, but it's the same hair. Right? So the quadratic function is still the same, the graph is still the same, but it's written a little bit differently. So in this case, we're writing it in intercept form. And I can tell you that my x-intercepts are related to my roots of the equation, which in this case are going to be 1 and 3. And the roots are those values of x which make y equal to 0. So if I wanted to find the axis of symmetry, let's just say I graph my equation here with the roots being 1 and 3. I have 1 here and 3 here. I know my graph opens up because the a value is positive. So it looks something like this. If I wanted to find my axis of symmetry, I know it goes right through the center of these 2 points that I've located, 1 and 3. And in fact, I can figure out what the axis of symmetry is by adding the 2 roots together and dividing by 2. So in this case, the axis of symmetry is going to be x is equal to 1 plus 3 divided by 2, or x is equal to 2. Now I have the value for the axis of symmetry. I can plug this value back into my equation and solve for y, and I have my vertex. So in this case, if I have y is equal to x minus 1 times x minus 3, then I plug 2 back in for x. I get y is equal to 2 minus 1 times 2 minus 3. Y is equal to 1 times negative 1, or y is equal to negative 1. So my axis of symmetry now is going to be 2, negative 1. When we talk about minimum and maximum values, the minimum or maximum value is always just the value of the y component of the vertex. So in this case, my minimum value is going to be negative 1. Now remember that the graph opens up when the a value is positive and down when it's negative. So when it opens up, I'm going to have a minimum value. So we see here a minimum value, and it opens down. When it opens down, I have in this case here, I have a maximum value.